Hi, and welcome to Chapter 2, Objective 3C. Originally, I had this particular objective combined with 2.3b, but many students have some difficulty calculating the opportunity cost. So I wanted to put it in its own objective, and that's exactly what we're going to do today is learn how to calculate opportunity cost. So by this point, you should be familiar with the production possibilities frontier, but now we're going to see how to construct it using numbers. Before it was more theoretical. This particular mathematical calculations will be really important in chapter 3. So it's paramount that you understand this objective in order to understand the objectives for chapter 3. So I put it off to the side in its own objective so that you could replay this if you needed to in the future. Without further ado, let me go ahead and share my screen with you. Okay, so as I said, this is learning objective 3C, where we're actually going to calculate opportunity costs. So some of these learning objectives we've already accomplished, but what we're going to do is really look at this from a mathematical standpoint. So hopefully you have a calculator ready. If not, press pause, go find one, and we'll go ahead and jump into it. Okay, so again, we're in the context of the production possibilities frontier. And what we've said is it really shows a lot of different combinations of two goods, and based upon the idea that we want to get and maximize our scarce resources, those resources being land, labor, and capital. So using an example, I think, is the easiest way to understand the methodology behind calculating opportunity cost. So here's our example. We have two goods, computers and wheat. At this point, you should be able to answer what's the opportunity cost of a computer? And right now, it's wheat. What's the opportunity cost of wheat? It's computers. But we want to become much more precise in that answer. So there is a trade-off between computers. If you decide to increase the amount of computers in, say, your business, then you automatically do so by decreasing wheat, okay? So because it's an opportunity cost, notice when one goes up, the other goes down. So we would say that the two products are negatively correlated. Okay, now because they're negatively correlated, that means that when we calculate this, the answer will be negative. But we already know that because we're looking at opportunity cost. So you'll see the formula later on, and that's when I say we're going to take the absolute value. We have one resource, and it's labor. So we're looking at one and only one resource. So if we were going to graph this, which we will, would it be a straight line or a bowed out shape? If you said a straight line, then you're correct. Because for us, learning the ABCs of economics here, the only time we'll be asked to calculate opportunity cost will be using one factor of production, and that 9 times out of 10 will be labor. Okay, we have 50,000 labor hours that we can use to produce computers, wheat, or some combination of the two. Okay, so this is where we're going and where we're going to get to, and I'm going to show you where all of these numbers came from, where this 5,000 comes from, where this 500 comes from, and so on. The reason I'm showing you this is the production possibilities frontier. Remember, anything inside the shape, and let me just highlight that for you. Anything in here is inefficient, on the line is efficient, and outside is currently unattainable given our current state. So we can't get out here, on the line is efficient and good. Now, there's one other thing I'd like to point out to you here and kind of jog your memory, perhaps, and that's the idea of the properties of a straight line in terms of mathematical principles. So one of the properties of a straight line is we know that the slope of a straight line is constant. So the slope is constant. What does that mean? It means if I pick 2 points, and I'll call this point A, and I'll call this point B, if I pick these 2 coordinate points and calculate the slope, it'll be exactly the same as if I picked A and C and calculated the slope, because the slope of a straight line is constant. The second thing I wanted to jog your memory about was that parallel lines have the same slope. So if I were to draw a parallel line here, that the slope of the red line would be the same as the slope of the blue line. So slopes of parallel lines are the same. Okay, so that's kind of important to remember as well. Okay, so how do you find the slope of a line? And many of you say rise over run, and that's fine. I'm just going to walk through the entire formula because for me, rise over run was always a little confusing. Okay. All right, so let's go ahead and use an example, and I'll show you how we get this. So in our example, again, we have computers and wheat, we have labor, we have 50,000 labor hours. Now, this is the important part. 1 ton of wheat, it takes 10 hours to produce, okay? And 1 computer takes 100 hours. So we need that information to calculate the opportunity cost. So essentially what we want to do here is to ask ourselves, okay, what's the opportunity cost of 1 computer? And we already know it's going to be wheat, but how much wheat? And likewise, what's the opportunity cost of 1 wheat in terms of computers? So we need a number, okay? And that's what we're going to do here in the next slide. Okay, so here again are 2 goods, 1 resource. We have 50,000 labor hours, and it takes, to produce 1 ton of wheat takes 10, 1 computer takes 100. Now, what I think is the best way to start this is to imagine that you're just going to produce wheat and you're just going to produce computers. So what do I mean? Okay, this is what I like to call the all and nothing approach. This is always where you need to start, even if you're going to take some shortcuts, which I will show you in a bit. Okay, so if I produce just computers, I have 50,000 labor hours available to me. It takes, reading the problem, 100 hours to produce a computer. So if I divide that by 100, I can just cancel my zeros, and I end up with 500 computers and no wheat. Okay, so that's an all or nothing approach. I'm just doing computers at this point. Now what I want to do is to take the same approach and just produce wheat. I'm going to take my 50,000 labor hours. Given in the problem, it takes 10 hours to produce 1 ton of wheat. So I'm going to divide that by 10, and I end up with no computers and 5,000 tons of wheat. Now, at this point, you may be able to see where these numbers are coming from. But the next thing I want to do is to draw the production possibilities frontier. Now, this was pre-drawn so that I didn't draw so poorly when I used my little instrument to write on the screen. But my question to you is this. I put wheat, remember that this is the x-axis and this is the y-axis. And I put wheat on the y-axis. Why did I do that? A lot of students will say, well, that's how you solved it over here. It looks like x and y coordinates. That's true, but if I chose to do it differently, I could have put 5,000 week, comma, 0 computers, right? And then it wouldn't be in coordinate point systems. So how do you know what goes on the y-axis? And this is kind of an important point. If you don't get it, then all of your graphs will be backward. You're going to look at the numbers that you have. I have 500 and 5,000. Because 5,000 is the largest number that I have, and that signifies wheat, I'm going to put that largest number and its corresponding good on the y-axis. So the largest number, that's how you'll make sure you always get it correct, okay? So by default, then, computers are on the x-axis. Okay, now you're right. I do want to go ahead and graph these coordinate points. So remember, the origin is 0, 0. And my first coordinate point, I have 500 computers. So I'm going to walk out 500 steps. I'm just going to put it right here. And I'm going to say that's 500 computers. How much wheat? Nothing. Notice that that is on that line on our x-axis. So this is 500 computers and no wheat. Okay. Now I'm going to graph the wheat. Let me go back, pick this one up. So now I'm going to graph the wheat. I'm not going to go out at all because it's 0 computers, but I'm going to go up 5,000. So I'm going to be right here, 5,000. So this coordinate point is out nothing, up 5,000. At this point, I think it's important to make sure that you understand that these represent items. So I'm going to say, hey, don't forget, these are computers. Hey, don't forget that this is wheat. Let's put W there, okay? Also, now note we have 2 points in a coordinate plane. When you have 2 points in a coordinate plane, what's great is, whoops, did that wrong. 2 points in a coordinate plane, and you can connect those points together. Not horrible for a straight line. Okay, so now what we actually have here is the production possibilities frontier for computers and wheat. But we still haven't answered the question. Every time I produce some wheat, how many computers do I give up, and vice versa? So to do that, I have to calculate the slope of this line. So let me pick something. Hopefully this will be easy to see. I'm not sure. So I'm going to put an X here, an X because the computers represent my X. And I'm going to put a Y for my wheat. And now I'm going to put 1s down here, 2s up here. It doesn't matter which you put where, okay? I mean, it doesn't matter. And now, yes, I'm going to use rise over run, but the formula for a slope is y2 minus y1 over x2 minus x1. And again, don't get lost in the math because we need to tease out economic answers later. So please, please, please make sure that you go into, when you're solving these yourself, that you go in and say, okay, Y's are wheat and X's are computers. I have a lot of students that use a lot of colored pens when they're doing this and so on. And that's perfectly fine, whatever works for you. Okay, at this point now, I want to solve this, and I want to go ahead and put my numbers in for my variables. So y2 is 5,000. y1 is nothing over x2 is 0. x1 is 500. Okay? Now, as I said in the previous slide, we already know this is going to be negative because it's an opportunity cost. So what we're going to do is to take the absolute value. Another reason we know that this answer will be negative is because the slope of this line is negative, right? Because it goes downhill. So I can go ahead and solve this, which I'm going to. And I'm going to say I have 5,000. And again, I have 5,000 what? I have 5,000 wheat, so I'm going to keep marking those. 2 and 500. Let me go back, grab it for 2. Come on, baby. Okay, there we go. 500 computers. I think changing the ink takes so much time here. Computers. So this is in fact a ratio. So I'm going to go ahead and take it to its simplest form. So those two cancel. I'm left with 50 wheat to 5 computers, which is also equal to 10 wheat to 1 computer. Now I have to continue to work the mathematical problem until I get a 1, either in the numerator, whoops, or in the denominator. I cannot stop mathematics until I have a 1 either up top in the numerator or down below in the denominator. Because I have a 1 in this instance in the denominator, I can go ahead and stop mathematics. And this is where we change up hats and now we become the economist and we interpret this ratio. Notice I didn't say 10 here. I said 10 wheat to 1 computer. So now I'm going to go ahead and become the economist. So I'm going to write a big econ there. And now I can say what this means. And I'm going to start with the one, the product that I have a 1 signifying. So that would be computers here. And I'm going to say the opportunity cost of 1 computer is 10 wheat. Okay? So the opportunity cost of 1 computer is 10 wheat. This means every time I produce 1 computer, I give up 10 wheat. So let's see what that really means over here on the graph. So if I am saying, let's just take half of each of these. So I'm going to produce 2,500 computers. I'm sorry, 2,500 tons of wheat and 250 computers. And I just want to use a middle point so that I could easily illustrate what I'm trying to show you here. So notice that, so every time I decide, if I decided to produce 251 computers, that would mean automatically that I would produce 10 less wheat. So I would be here at 2490, let's say. Again, not drawn to scale, but I wanted to show you. It means that as I move down the Y 10, then I move out the X of 1. Okay? Now this is only half of the answer. So we got it half right, okay? I also want to know what is the opportunity cost of 1 ton of wheat. And here what I do is come back to the original and I'm going to take the reciprocal, and the reciprocal just means to flip it. So that must mean then that the opportunity cost of 1 wheat is 10 over 1, which is 1/10 of a computer. So that shows me that if I want to produce more wheat, if I want to go from the origin up, then I'm automatically going to be coming in 1/10 of a step. Okay, so it's kind of how these two axes are working together. So this is my completed answer here now that I have both the opportunity cost of both products. Okay, now what if we were to use this example and we don't get a 1? Because sometimes that happens. So let's say that I worked all the math and I ended up with 3 wheat to 2 computers. Well, I can't really do anything else, right? This is in its lowest form. Yes, it's in proper form, but it's in its lowest form. but remember to keep it as a ratio. So this is actually 3-2. If you'd rather, you can say 3 wheat, 2 computers. Sometimes people see it more intuitively what you should be doing here. I have to get a 1. There's no 1. Okay, so when there's no 1, what you can do is to divide both the top and the bottom by either the numerator or the denominator. So because the 2's on the bottom here, that's the one I'm going to take. So I'm going to divide 2 by 2, and I'm going to divide 3 by 2. And when I do that, I get an answer that says 3 halves wheat to 1 computer. Now I can go ahead and be the economist. I can say the opportunity cost of 1 computer is 3 halves, and we're going to say 3 halves improper, 1 1/2 wheat. The opportunity cost of 1 wheat is, and now I'm going to take the reciprocal. Oh, stop that. Like I said, grabbing this stuff is interesting. I'm going to take the reciprocal of the 3 halves, which we know is 2/3, and I'm going to say is, if I can find my pen, there we go, is 2/3 computers. Now, again, I can have some really good information to really precisely understand the opportunity cost of each product. As I decide to produce more computers, I give up 1 1/2 wheat in this slide. If I decide to produce more wheat, I give up 2/3 of a computer. Okay. So when we look at this, we can see all of the combinations. I like to use the endpoints because it really makes the math easy. So what I did essentially was to use A and say we're just going to do computers. So that gave me my computers axes, and we're just going to produce wheat. So I use points A and E. So those are the 2 that I went for. But notice there's many points in between. Okay, I'm going to go back to the previous slide for just a moment because I want to tell you something else. So now that we have 5,000 tons of wheat and 500 computers, we know that anything, there we go, move that over, cheat a little bit there, make it really big. Okay, so we know that any points along this line will abide by a 10 wheat to 1 computer ratio. Now, there might be additional production possibilities, frontiers that we don't see. So a question I often ask on the tests are, which of the following would not be a PPF, or a production possibilities frontier, for these goods? And what you want to do is look at which ones abide by a 1 to 10 ratio. So maybe we have, I'll put 4 answer choices. So we have 110. We have 1,000 and 900. We have million and 10 million. Okay. And we have 1 in 10. Okay. Now you can see, is this a 1 to 10 ratio? Yes. So you look at this and you ask yourself, what's the highest common multiple? That's the highest number that goes into both. Well, the one that goes into both evenly here is 10, right? 10 goes into 10 once, 10 goes into 110. So that's a 1 to 10 ratio. Here, highest number goes into both is 100. So that's a 10 to 9 ratio. Highest number goes in here is 1,000,000. So that's a 1 to 10 ratio. And highest number here is 10. So that's a 1 to 10 ratio. So as you can see here, A, C, and D all fit. The one that is not on the production possibilities frontier would be B. So you'll see those types of questions as well. I also wanted to take a moment, and I'm going to erase this slide for a second, and show you a shortcut. And if you're good with the math, by all means, use the shortcut. So I'm going back to the original problem, and remember we started off, and you have to use the all or nothing approach even if you're using a shortcut. So I'm taking the 50,000 labor hours, going to divide it by the number of hours it takes to produce one computer, so that's 100, and I end up with 500 computers. I'm going to automatically now go to wheat, and wheat, 50,000 labor hours, takes 10 hours to produce, so that gives me 5,000 wheat. What I can do here, skipping some of the logic of this, if you will, or the steps, and again, everyone's is comfortable doing it differently. Math is cool that way, that you can do it different ways. So I'm just going to go ahead and set 5,000 wheat to 500 computers. What's the highest common multiple that goes into both? 500. So, or I can just do this, and I can see that it is a 10 wheat to 1 computer ratio. At that point, I can go ahead and list the opportunity cost of 1 computer is 10 wheat, and the opportunity cost of 1 wheat is taking that reciprocal 1/10 of a computer. So if you don't have to graph it, that's really quite nice to do it that way. If you are given a graph, you can many times just look at the endpoints of the graph and see what is the highest common multiple that goes into both. So let's say we have over here, I'm going to try to use different numbers, 3,000 wheat, and we have how do I use that? We have 500, let's say that. So we have, nope, just a minute. Teaching online sometimes. Okay, let's see if I can do this. Okay, there we go. Okay, 500 computers. And this is the graph that we're given, and then it asks us what's the opportunity cost of wheat in terms of computers in terms of wheat. So I'm going to look at my endpoints, and that's the first thing I'm going to do. And I'm going to say I have 3,000 wheat, I have 500 computers. What is the highest common multiple? And I know that's weird because we don't think in those terms, but what's the biggest number that'll go into both evenly? So if I look at this, 500 goes into 500 once. So I'm going to put a 1 there for computers. 500 goes into 3,000. How about 6 times? 6. So I can say I have a 1 computer to 6 wheat. So the opportunity cost of 1 computer is 6 wheat. And the opportunity cost of 1 wheat is, taking the reciprocal, 1/6 of a computer. Okay. Again, that's why I decided to break this out into its own lectures, because again, this is some stuff that's kind of difficult, I think, many times for people to wrap their heads around. We're not used to thinking particularly in ratio form. Okay. All right. On the graph, find the point that represents 100 computers. And okay, 100 computers. Right, so let's go ahead and look at 3,000 tons of wheat. Graph. Label my screen again with you. Would it be possible for the economy to produce? So here we have wheat and computers, and again, there's our 5,000. And our next question will say, next, find the point that represents 300 computers and 3,500 tons of wheat, and label it G. And then would it be possible for the economy to produce this combination of the two goods? So here's our little chart, okay? So we have A through E, and remember I just picked those endpoints, and we've calculated the opportunity cost already. So let's take a look at our first question. Sorry. Find the point that represents 100 computers and 300 tons of wheat. Okay, so 100 computers, that's going to be right here, and 3,000 tons of wheat. That's going to be right here. Now I want these two to intersect. So essentially what I'm doing is I'm just coming up here, coming over here. So here's our point that it's asking us to find. Would it be possible for the economy to produce this combination? And the answer to that is yes, it would be possible. But it is not, it is an inefficient, right? Because it's inside the production possibilities frontier. So it's inefficient because if we look at this at the point of 3,000 wheat, I could be producing 200 computers, right? So I could be here, right? Or at 100, I could come up here and I could produce 4,500 tons. So it's inefficient because we have labor being wasted. Okay. A good example of when we've been inside the production possibilities frontier recently is Corona. So labor was out because much of labor was sick. So we were inside the production possibilities frontier, not where we want to be. Okay. Okay. Next, find the point that represents 300 computers and 3,500 tons of wheat. Okay. And label it G. Okay. So now we're going to, again, I'm just going to start down here at 300. And here's 3,500 right about there. I'm going to go ahead and follow that up. And it looks like it would be right about there. And I'm going to label that G. Now, is G a good point to be? Okay. Would it be possible for the economy to produce at G? And the answer is no. There's not enough labor currently. This point, point G, is unattainable given our current state. And you'll see why in chapter 3 I say that. Okay, so G is unattainable. Only points A through E are both efficient and attainable. Okay. All right, so there's our answers. F would be inside again, so it is inefficient. And looking at G, G is not possible at the current state. Okay, so here is an example problem. We have Argentina and Brazil each have 10,000 hours of labor per month. We're just focusing on Argentina. 1 pound of coffee requires 2 hours. 1 wine requires 4. So the first thing I want to do is do the all and nothing approach. I have 10,000 labor hours, and I'm going to imagine first I'm just doing coffee. Okay, so just doing coffee, it takes 2 hours to produce coffee. I end up with 5,000 coffee and no wine. Okay, I'm just going to produce wine. Actually, I should trade up colors so we can keep these kind of straight. So let me trade up colors here. Sorry, it always takes me so long to do that. But, okay. So now I have 10,000 labor hours. I'm looking at wine only. And 10,000 divided by the 4. So I have no coffee and 2,500 bottles of wine. This particular problem did not ask me to graph it, but some students like to graph it. So I'm going to go ahead and put in a graph. Yeah, you can tell I use pre-drawn ones. This will be X and this will be Y. How do I know what goes on the y-axis? So let's take a look. I've got 5,000 coffee. I have 2,500 wine. Because coffee is the highest number, coffee is going to go on the y-axis, and by default, wine is going to go on the x-axis. So I can produce 5,000 coffee. So I'm going to go ahead and put a mark right there. 5,000 coffee and no wine. So this is 0 wine and 5,000 coffee because I do want to put it in the X and Y ideology. Okay, so for our wine down here, we're not going to produce any coffee, so I'm not going up at all, but I'm going out 2,500. So this would be 2,500 wine and no coffee. I have 2 coordinate points, so I can connect them with a straight line. And now I can take a look and label these in terms of the ideas of a slope. So I have X, X, and Y. I'm going to make these 1. It's just how I was taught. So, and 2. I'm going to go ahead and plug this into my slope formula. Y2 minus Y1 over X2 minus X1. Remember to take the absolute value. And then we're going to label what these stand for. Coffee to wine. So Y2, I'm going to go ahead and plug that in. 5,000 minus 0 over 0 minus 2,500, which gives me 5,000 coffee to 2,500 wine. And I know the highest common multiple that goes into both is 2,500. It goes into 2,500 once, and it goes into 5,000 twice. So now I have a 1 in the denominator, and I can go ahead and become the economist and interpret this. So now we know the interpretation here is going to be that the opportunity cost of 1 wine is 2 coffee. The opportunity cost of 1 coffee is, and again, take the reciprocal, 1/2 wine. And that answers my question. Okay, here's another example. In which country is the opportunity cost of cloth lower? Now, in this example, we're going to look and we're going to say, okay, if I have 300 and 600, what's the highest common multiple? So we're going to use that highest common multiple. And the highest common multiple that goes into 300 and 600 evenly is 300. 300. So I have a 1 cloth to 2 wine ratio. So in France, the opportunity cost of 1 cloth is 2 wine. That's what we give up. In England, so now we can go ahead and look and we can say, okay, what's the highest common multiple that goes into both and goes into both evenly? Here's where I'm going to go, okay, 100. So if I divide that by 100, I end up with a 3 cloth to 2 wine ratio. Now remember, I can't talk about opportunity cost until I get a 1 either in the numerator or the denominator. So I'm going to say it's a 2 wine to 3 cloth ratio. And here's where I'm going to divide through, and I just always use the 1 on the bottom because it's less messy. So 3 and 3, and I end up with 2/3 wine to 1 cloth. So therefore, the opportunity cost of 1 cloth is 2/3 wine. Well, which would you rather give up? Would you rather give up 2 wine or 2/3 wine if the only 2 resources on the planet were cloth and wine? I don't know about you, but I would much rather give up 2/3 of a bottle of wine, particularly some days. Okay, so England is going to be my answer. Okay, well, hopefully these provided some additional clarity on how to calculate the opportunity cost. I'll see you in the next objective where we talk about the difference between micro and macro. And then we talk about, subsequently, we're going to discuss the difference between positive and normative statement. And then we finish up the chapter with statements on which economists agree and disagree. So I know there's a lot in 2, and I know you may want to go back and review some of this stuff, particularly when we start working with it again in 3. Thank you for your time and attention. Have a great day.